Okay, a reminder that when you solve a system, you are looking for the point that works in both of them, or the x and the y that makes both equations true. So solving with elimination allows us to temporarily get rid of one variable so we can find the value of the other one, and then we can go back and find the one we temporarily got rid of. So with elimination, some visual things you're going to look for is the like terms are going to be stacked. So the x's are on top of x's, the y's are on top of y's, etc. And then we're going to be looking for opposite like terms. So when we add 5 and negative 5, they go away. When we add negative 2x and positive 2x, it disappears because that zeroes stuff out. So that's what we're going to be looking for, stacking and opposite like terms. So just to make sure you understand, when I say opposite like terms, what am I talking about? Like terms have to have the same variable. So the ones I underlined have the same variable, but we also need to have the same power. And the same power means the same exponent. So the 2x and the negative 2x are opposite like terms. They have the same variable, same exponent, and their coefficient, the number in front of them, are opposites. And what happens when we add opposite like terms is they zero out. So the green ones zero out, and the red ones, I've got 3x squared and 5x squared, so I'd have a total of 8x squared. Notice, by adding opposite like terms, I've temporarily gotten rid of the x's. The only thing I have to deal with now are the x squared. So like terms, same variable, same exponent, and by creating opposite like terms, one of the variables in the system will temporarily drop. So elimination works to eliminate or get rid of one of the variables for a moment by using opposite like terms. So first thing we want to check, are they stacked? My x's are real close to my x's, my y's are real close to my y's, my numbers are real close to my numbers. Mine aren't perfectly stacked, but you know, I'm making the video. It's not perfect. But you'll notice that here, the negative 2 in front of the x and the positive 2 in front of the x are opposites. And the x and the x are the same variable and the same exponent. So when I add negative 2x and positive 2x, they zero out. Negative 2x and positive 2x is 0. And then 5y and 3y is 8y. I'm going to add those like terms. 10 plus 6 is 16. Now notice I've temporarily gotten rid of the x. And I have enough information to find out what y is. So I can go ahead and I can finish my equation. Whoops, something's in the way here. I'm going to divide both sides by 8, and I know that y is 2. Okay, so once again, they're stacked. Opposite like terms allow me to solve for one variable. I'm not done yet. I need to find, I know that y is 2. I need to find out what x is. So I'm going to show you how to do that on the next. Now this is what we just had, and we found out that y is 2. So we need to find out what x is. And so we can plug 2 into y either here or here. And when I plug it in, when I say that, I'm going to substitute the variable y for the number 2, because I know that we want to find out what the x value is when y is 2. So I'm going to just use the second one. 2 times x plus 3 times y. Well, I know y is 2. So I'm going to substitute that, equals 6. And then I go ahead and solve for the value of x. Same process that we've been doing with our opposite operations. 2x plus 6 equals 6. And then I'm going to subtract 6 on both sides. That's going to get rid of these. And add up 2x is 0. And then dividing both sides by 2, I get x equals 0 divided by 2. So x is 0. I found the value of the variable. I didn't say that right. I found the value of the point that works in both of them. What if they're not stacked right, or what if they don't have opposite like terms? What can we do? Well, one of the first things you can do is rearrange them so they're stacked. So I'm going to go ahead and take the top one and rewrite it. It's just like it is. And then I'm going to rewrite the bottom one so we have the x's right on top of the x's, the variables right on top of the y's right on top of the y's, and then the numbers. So I've rearranged them, and then I want to, do I have opposite like terms? I do not. But my like terms are right on top of each other, so then I can look, okay, here. I have 3, and I could either make this number -3, that's one thing I can do, or I got a positive 1y and a positive 1y there. The other thing I could do is multiply by -1. So that seems easier. I'm just going to take this one and I'm going to multiply the whole thing by -1. Okay? So I would end up with -1x, -1y, -3. So I multiplied this by -1, so I could end up with, here's my opposite like terms now. I've got, oops, I've got positive 1y and -1y. So when I add straight down, I'm just going to write that down for you. I multiplied by -1, so my y's were opposites. And whenever you multiply by all the terms. This one, and this one. So 3x and a -1x is 2x. 1y and -1y is zeroed out, exactly what I'm looking for. 5 plus -3 is 2. So now I can finish the equation. I find out that x is 1, and I want that rest of that point. If x is 1, I can go ahead and replace, I'm going to go ahead and let x equal 1 here. So y has to equal 2. 2 plus 1 is 3. So once again, this one we don't have to rearrange. The x's are on top of the x's, the y's are on top of the y's, the numbers are on top of the numbers. And so if we want to use elimination, then we're going to either look to see how I can get the x's to have the same number in front of them. Whoops, I don't know how I got red there for a second. Or I'm going to look to see how I can get the number in front of my y's be the same. So last time I dealt with the y's, this time I'll deal with the x's. So if I want the numbers in front of the x's to be the same, I'm going to multiply the bottom one by what number? By -2. So the top one's going to stay the same. -2x plus y, whoops, I forgot about the x, plus y equals 3. And then the bottom one, -2 times x, I don't want to multiply by -2. That doesn't make any sense. I'm going to multiply by +2. Let me erase that. I'm going to multiply by +2 because that will give me the opposite like terms. So if you're wondering, what is she thinking? It's because I'm goofy. So the bottom one I'm going to multiply by +2, so I get 2x plus 2y equals 6. And now I have the opposite like terms that I want. Those cancel out. I get 3y equals 9. Divide both sides by 3. Y equals 3. And then all I have to do is plug it in for y is 3. So that means that x has to be 0. So with this one, I'd like you to think about what you would do. Are they stacked properly? Okay, write yours down. What would you do to fix that part? I'm going to go ahead and rewrite this one underneath. And then I think it would be easiest for me to go ahead and get the ends so they're like terms. So I'm going to multiply the bottom one by -5. That will give me a -5q, a -5n, and -75. Then I'm just going to go ahead and take this equation and write it underneath it. I'm just going to take this. Oops, it's not letting me write. Sorry. I'm just going to take the 25q and the 5n and the 175, and I'm going to add them straight down. I'm going to get 20 q's and no nickels and 100, so 20q, that q would have to be 5. And since I have 5 quarters and I know that there are 15 total, then the number of nickels would be 10. So key stuff is, if they're stacked, make sure that they're stacked by like terms, and then if you need to, multiply to get opposite like terms. Page 13 in your packet is the packet page that you would work on to practice these. And there we go.